Okay, 5.4. I want to do some reviewing first, okay? I want this expression factored completely. 1x to the fourth minus 12x to the second minus 64. Now you're not finding the answers, that you're not solving an equation, you're rewriting that into as many parentheses as you possibly can. That's what factoring is. So it's not a quadratic, it's not x second, so you count the terms, there's 3, okay? So to factor 3 terms when it's not quadratic, I kind of do it the same as a quadratic. I make my GCF and I make my table. Sorry, I'm not very coordinated. I can't hold the camera and make good boxes at the same time. 112 and 64, the GCF is 1. Now, do you have an x on your last term? No, so you don't put x. Okay? And is the first term negative or positive? It's positive, so GCF is positive. Okay, well, I'm not doing that then. That's a bunch of crap. Now, ABC, like you would with a quadratic, and you take 1 times negative first term times the last term, just the coefficient, so negative 64. So to multiply to negative 64, well, we know the numbers have to be a positive times a negative. And we're adding, they have to add to negative 12. That's the middle term. Okay, 1 and 64, not even close. Divide by 2, you get 32. Nope. 3 is a decimal. You divide by 4, you get 16. Bam. Okay, so you add those, negative 12. There it is. If you multiply 4 and negative 16, it's negative 64. If you add them, it's negative 12. That's right. Focus on your A. Just write what A is with its variable and exponent. Okay, if A is 1, well, get rid of that. And you just need 2 parentheses, but it's x to the fourth. How do you break down an x fourth? Well, probably x second, x second. Plus 4 minus 16. Now, transfer those up here, and we're going to inspect them further. Now, the one with a plus, I don't care if it's perfect squares, it's done. It can't be factored. It's difference of perfect squares, not plus of perfect squares, okay? Now, this one here is a minus. Last time I checked, 16 was 4 times 4. And then x to the second is x times x, okay? So we rewrite that. X, 4, 4. Now again, that's got a plus, so it's done. Now that has a minus, and yes, 4 is 2 times 2, but x without an exponent cannot be broken down, so you pull that down, okay? And that's it, x squared plus 4 times x squared plus 4 times x plus 4 times x minus 4. Next up, x to the fourth power minus 64, okay? Now, there's 2 terms here, so GCF and DOPS. Difference of perfect squares. Okay, 1 and 64 is 1. That does not have an x, so don't put 1 there. The last term doesn't. And the first term's positive, so GCF's positive, so out. Okay, DOPS. Okay, you got your minus. Let's talk about 64. Well, yeah, it's a perfect square. It's 8 times 8. We can ignore the 1. X to the fourth, yeah, it's a perfect square. It's x to the second times x to the second. So I put x second plus 8 minus 8. Okay? Now bring those over here for further inspection. X squared plus 8, x squared minus 8. That's a plus, so it stays like it is. That's got a minus, but 8's not a perfect square. It's not 4 and 4. 4 times 4 is 16. Okay, there's no 2 numbers that can multiply out to 8, so that is finished. So that's it, x squared plus 8 times x squared minus 8. Now if that was a 16, yeah, that'd be different. That'd be x minus 4. But 8, no. Okay, now I want to work on some simplifying with exponents. Simplify 3 to the second times 3 to the third. Now, I mean, if you want, you can go the long route and just do your 3-step process, okay? So number base, you have a 3. Now there's 2 3s, so that just means I'll add the exponents. 2 plus 3, that's 5. Okay? Obviously that's a positive, so it would stay on top, okay? And 3 to the 5th power is 243, so that's the answer. Okay, next problem, we have 3 to the power of 6 divided by 3 to the power of 4. So if you really want to break it down, okay, new number base on top's 3, it's to the 6th power. Number base on bottom's 3, it's to the 4th power. Now, when we have the same base on top and on bottom, we take out the small one with the smaller exponent, minus it to the top. So 6 minus 4 is 2. So now I have 3 to the power of 2. Well, that's not going to go anywhere because it's positive, and then 3 to the 2nd power is 9. Okay. Okay, next problem. I have 3 to the power of 3 in parentheses, and then to the 2nd power. So if you really want to get technical about it, your base is 3. It's the only base you have on top. Now to find its exponent, you have to distribute 2 to 3. That'd be 6. Okay. Well, that wouldn't go anywhere. It would stay 3 to the 6th. Okay. And 3 to the 6th power is 729. Remember, it's not 3 times 6. Okay, next problem. 3 to the negative 3rd power. So the only number base is a 3. It's the only base on the top. It's the only base in the whole problem, negative 3rd. Now, I have a negative exponent. So guess what happens to your base? It goes to the bottom, so now it can have a positive exponent. Now you need to have a top number be 1. You can't just have it on the bottom with no top. That looks ridiculous. Okay. Then 3 to the 3rd is 3 times 3 times 3, which is 27. 1/27. Okay, next problem. We have parentheses, 3d to the 2nd power, and then the parentheses is closed, and then we have the 3rd power, and then times 2d to the 2nd. So, this one definitely with the lines would be the way to go. So underline it. The two numerical bases on top are 3 and 2, so 3 times 2. Don't write 6 yet, don't. These have exponents, I'll figure out. And you have a variable d on top. Now we have 2 of them on top, so that will involve adding their exponents together. Okay, let's figure out the exponents. 3 would be to the 1st, and I distribute 3 to 1, that'd be 3. 2 would be to the 1st, and there'd be no distribution because it's not in parentheses. No, you don't go 2 to 1. That isn't in parentheses, so it's just a 1. And then d, there's 2 d's. First one to the 2nd, but we have to distribute 3 to 2, which is 6. And then the other 2d is to the 2nd. 6 plus 2 is 8. Well, that's a positive power, it stays. That's a positive power, it stays. And that's a positive power, so they all stay where they're at. Okay, 3 to the 3rd evaluates to 27. 2 to the 1st evaluates to 2, and then d to the 8th is d to the 8th. But 27 times 2 needs to be multiplied. That's going to be 54. So 54 times d to the 8th is the answer. Okay, next one. We got a parentheses 3x, and outside you got a negative 4th power. Again, this strategy can be utilized anytime I'm simplifying exponents where there are no adding or subtracting operators. So I have a base 3 and a base of x. Just one of each, so no adding. Negative 4 distributed to 1 is negative 4. Negative 4 distributed to 1 is negative 4. Well, guess what happens to these negative exponents? They need to move to the bottom, both of them, so they can be rewritten in positive exponent form. Now 1 now occupies the top. You have to have something occupying the top. Okay, 3 to the 4th evaluates to 81. 3 times 3 times 3 times 3, and then x to the 4th. And That's my answer, 1 over 81 times x to the 4th. Okay, next problem. No number base is on top. You have a variable base on top of x. Now go to your bottom. No number base on bottom. You have a variable base on the bottom of x. The fact that there's two of them means we'll just add. So the top x would take a base of -2, and the bottom we add 3 plus 2. Now 3 plus 2 is 5 last time I checked. So x to the -2nd, x to the 5th. We need to cross out one of the x's, the one with the smaller exponent, okay? And then when you cross it out, you minus that exponent, which is -2 from the bottom. So that's 5 minus -2, which is plus 2, which ends up as 7. So at the end of the day, you don't have anything on top, so you fill it with a 1, and you have x to the 7th on bottom. So the 1 stays put. And guys, if it has a positive, you don't move it. You don't say, oh, it's positive, it goes at top. No, if it's positive, it stays where it's at. And then you can't evaluate the exponents, so that's your final answer. 1 over x to the 7th. Okay, next problem. Parentheses 2e to the -4th, and then g to the 5th. And then on bottom, you got e to the 5th, g to the -3rd. So you have a top and a bottom. So let's talk top. Number base is 2. Variable base, you got e, just one of them, on top, and a g on top. No number bases on bottom, you have an e, and you got a g. Now let's talk top. -4 times 1 is -4. Now on the e, -4 times 1 is -4. G, you got 5. Now let's go to the bottom. Well, that's easy. It's just 5 and -3. Now, don't move here because you look at your bottom. I got an E on bottom. Do I have an E on top? Absolutely. So you get rid of the one with the... You don't just get rid of the one on top or the bottom. You get rid of the one that has the smaller power. And then minus that power, -4 from the bottom. So plus, that would be e to the 9th. Okay? Now look at your g's. This one has a smaller power. We get rid of that. Minus -3 would be plus 3, which is 8. So at the end of that, I have 2 to the -4th, g to the 8th, because I cross the e out, and then e to the 9th, and I cross the g out. Now I think that needs to change. So I send 2 to the bottom, so it's 4 becomes positive. I keep the g to the 8th where it's at, and I keep the e to the 9th where it's at, which is on bottom. Don't move him to the top. When you move it across the line, then it's got to go to negative. You don't want that. So g to the 8th, 2 to the 4th, 2 times 2 is 16. Times e to the 9th, okay? Okay, then I want to review end behaviors of graphs. Identify the end behavior. So it says y equals -8x to the 7th plus 16x to the 6th plus 9. End behavior is asking, as x approaches positive infinity, that means on a graph, okay, you don't need the graph paper, but as you go that way, what happens to our function? Negative infinity means as you go this way, what happens to the function? Okay. Now, the positive infinity part for x. Put leading coefficient is -8, and it's negative. So that means as x goes this way, y would approach, go to negative infinity. Just go down, down, down that way. Now, the other end behavior on the other side, okay, the negative side of the x, depends on your degree, the highest power, and whether it's even or odd. 7, that's odd. So the end behaviors are the opposite. So if that's negative, that's going to be positive. Okay? Next one. First off, you got a problem here. Y equals 1 minus 4x minus 6x to the 3rd plus 15x to the 6th. that's not in the right order. X to the 6 comes first, which is 15. Then the next highest is x to the third. Then the next highest is 4x, then plus 1. Now I'm in a good position. So the leading coefficient is positive 15. It's positive, so that means y approaches positive infinity along with the x. Degree. Degree is 6. That's your highest power. That's even. So that means the end behaviors have to be the same. Okay, so if that's positive, that's positive. Okay, next one, is that in the proper order? X third, x constant. Yep, it is. So the leading coefficient is positive 1. It's positive, so positive infinity. The degree is 3, third power, which is odd. It's the highest exponent, which means the end behaviors are opposite on each side. So if it's positive on that side, it's negative on the other. Okay, next one. Y equals x to the fourth minus 7x third plus 3. That's in proper order. So the leading coefficient is 1, but it's positive. So positive infinity along with the x. Okay. And then the degree is 4. Last time I checked, 4 is an even number. So if that's positive infinity, if it's even, they have to have the same end behavior. Odd, opposite, even, same. So they would both go, they would go up, the graph would go up that way, and it would go up that way.